Yes, good. Which kind of load? Yes, mention name of the load. Good. Which type of load? Yes. Okay. Okay. Fine. Okay. Fair enough. Chaliye. We will recall all the loads once more again. We will recall all the loads once more again. Just a minute. Okay. I am starting the lecture within a 1 minute, so some more people can join. Okay, fair enough. So let me start again. Surely. We have discussed in yesterday's lecture types of load. Okay. Before starting types of load, let me just recall this topic. First of all, we have discussed number of equilibrium condition. Number of equilibrium condition. Yes or no? That is for first is for coplanar. First condition is for coplanar on current force system. The second is for coplanar non-concurrent force system. Yes or no? Students, please give me. चलो હવે ડિસ્કસ કરેલું. રાઇટ ડાઉન નંબર ઓફ કન્ડિશન ફોર અ કોપ્લાનર કોન્કરન્ટ ફોર્સ સિસ્ટમ. ચલો આપણે ઓલરેડી ડિસ્કસ કરેલું છે. રાઇટ ડાઉન in the chat box number of equilibrium condition for a coplanar concurrent force system. ચલો એ લખો. કેટલી equilibrium condition હતી coplanar concurrent force system માટે? we have already discussed. જે સ્ટુડન્ટને ખબર નથી એ just recall કરી લો and go through recording. I will share recording today. You can watch in what that concept in recording. ચલો ફટાફટ આપણે 5 મિનિટમાં recording પૂરું કરવું છે. Please give me answer. Okay, good. Thus, so we have discussed number of equilibrium condition for coplanar concurrent force system. That is a 2 only, because all the forces are acting at a point, single point per lakse. That's the reason possible movement will be a 2 only. That is only translation, either movement in a x direction or y direction, and that to equilibrium condition is nothing but sigma fx equal to 0 and sigma fy equal to 0. But whenever we are considering coplanar non-concurrent force system, we have 3 equilibrium conditions. Keep in mind why 3 equilibrium conditions. Please go through recording. If you don't know, I am sharing same recording today. Don't worry. Okay. So we have 3 equilibrium conditions: sigma fx equal to 0, sigma fy equal to 0, and sigma moment or sigma moment z equal to 0. So we have a 3 equilibrium condition for a coplanar non-concurrent force system. So keep in mind, in this particular topic, we will discuss this particular concept. આપણે આ 3 equilibrium condition નો use કરીશું to analyze any problem. Okay. So we have a 3 equilibrium condition for coplanar non-concurrent force system. Now then after we have discussed types of support. Yes or no? Then after we have discussed types of support.
Yes sir.
क्या support है? चलो first types of support. First hinge support. Yes or no? कितना reaction आवे hinge पर? Write down in chat box. चलो how many number of reaction on hinge support? Write down in chat box. Okay, 2 reaction, vertical and horizontal only. Second is the roller support. Symbolic representation is just like this. it contain only one reaction, normal to its surface, as we have discussed. And third support is a fixed support. Symbolic representation is just like this. It carry a three reaction, vertical, horizontal, and moment. Now, why three reaction? Why two reaction? Why one reaction? We have already discussed in day before yesterday's lecture. Yes or no? So, if you don't know, please go through recording. You will get all the concepts. Now, next we have discussed types of load. First kind of the load is a point load. Okay, if your load is acting on a point, or if your load acting over a surface, and your area of the connecting surface is negligible, such kind of load is known as a point load. Okay, point load કોને કહેવાશે? area of the contact will be a negligible, such kind of load is known as a point load. If I am apply the load through a pen, okay, vertical pen થી load apply કરીશ તો એનો જે એરિયા છે સરફેસ પર એ negligible હશે, તો we can say it is a kind of the point load. Symbolic representation P વડે ડોનેટ થશે. We can say 5 kilonewton, 10 kilonewton, unit is a kilonewton, newton, depending on requirement. Now, then after we have discussed uniformly distributed load. Then after we have discussed uniformly distributed load. Uniformly distributed load short form is nothing but UDL. Yes or no? Short form is UDL. Now, as we have discussed, uniformly distributed load is nothing but it is acting over a surface having a equal intensity. Yes or no? एक सरखा intensity load लागશે. Its symbolic representation is just like the W per run. And as we have discussed, total load of UDL, total load of uniformly distributed load, that is nothing but point load of uniformly distributed load, that is equals to intensity of uniformly distributed load multiply by length covered by UDL. Yes or no? As we have discussed. Yes or no? Yes.
Yes,
area
sir.
of rectangle is right one. Area of rectangle is right one. Okay. Chalo. This is a procedure to convert a UDL to point load. How we will convert UDL to point load? Considering the intensity of load, keep in mind this word length covered by UDL. It is very important. Length covered by UDL we will discuss in numerical problem. Now, whatever the point load we have converted from this UDL, it will be act at a center of gravity of length of UDL. Yes or no? This point load act at center of length of UDL. Yes or no? Yes or no? UDL ની length ના center માં લાગશે, as we have discussed. યાદ રાખજો, આની જરૂર પડશે આગળ. Is it clear or not? Please confirm me, students. જે સ્ટુડન્ટ
Yes, sir.
થોડી ઘણી તો ખબર પડે છે ને, સાવ બાઉન્સ નથી તો please confirm in chat box. Let me know first of all who's today કોનો આજ પહેલો લેક્ચર છે, કોનો? ચલો પહેલા મને કહો. કયા સ્ટુડન્ટ આજ પહેલો લેક્ચર છે? Let me know first of all.
Hello, sir.
Yes. Type in chat box.
Sir, Keval Patel.
No doubt. No problem. Type in chat box. I will type in chat box. Okay. So only one student today. No problem. So no problem. What to do for new students? I will tell at the end of the lecture. Lecture end માં હું કહીશ તમારે શું કરવાનું. ઠીક છે? Fine. This is a uniformly distributed load. Next kind of the load is a uniformly varying load. Yes or no? Next load is the uniformly varying load. Its short form is UVL. Okay, its short form is a UVL. Okay, yes. Now uniformly varying load, that means now your load is a vary, that is not a constant at every point, but your load is vary from one point to another point, but variation is uniform. Yes or no? But your this variation, whatever the variation happen on every point, that variation is uniform. Yes or no? Please confirm me.
Yes, sir.
Okay, so we can represent like this: w per run, w per run. So what do you mean by variation of the UVL? Suppose you are uniformly varying load having a value 50 kilonewton per meter, 50 kilonewton per meter, and your length of the UVL, that is a 5 meter. Your length of UVL is a 5 meter. So if I am divide this 5 meter in 1 meter part, if I am divide this 5 meter in 1 meter, this 1 meter, this 1 meter, this 1 meter, this 1 meter, and this one, 1, 2, 3, 4, 5. Yes or no? So can I say here your value is 0? From this point to this point, your variation is a 10 kilonewton. From this point to this point, your variation is again 10 kilonewton. Again, this variation also 10 kilonewton. Again, this variation is also 10 kilonewton. So 10. Now total load 10 plus 10, 20. 10, 10, 10, 30. Are you getting my point? Yes or no? Please confirm me. Students?
Yes, sir.
Okay, fair enough.
Yes,
Chalo.
sir.
Now our main intent to determine or to know total load of the uniformly varying load, as we have discussed in yesterday's lecture. Total load of the any particular load, that is nothing but area consumed by that particular object. Yes or no? Total load કેટલો હશે? area જેટલો હશે એવું કહી શકાય. So can I say that total load of this uniformly varying load, that is equals to, now this total load will be act like a point load, that is nothing but your point load of UVL. Yes or no? Because that load
Yes,
is
sir.
acting on a single point load of uniformly varying load. Okay, that is nothing but area of triangle. Area of triangle. Why area of triangle? We visualize such kind of load as just like a triangle. Okay, area of triangle. That is nothing but 1/2 into intensity of load multiply by length covered by load. Yes or no? Yes or no?
Yes, sir.
Okay, now as we have discussed in case of the uniformly distributed load, your point load will be supposed to act at the center of the length. Yes or no? Center of the length of uniformly distributed load. Yes or no? But in this case, can I say that your total point load will be at the center of this triangle? Yes or no? Chalo, total load हमारा triangle ना center में लागसे. My question is that, again our question, listen to me very carefully. My question is that this total point load, this point load will be act at a center of triangle. Yes or no? No. One student saying no.
No.
I want. Please give me
No,
answer.
sir.
Please give me answer in chat box only. So lecture is not interrupt. Okay. Just one student give me answer. There are 26 students in room. Please give me answer. Why no? Chalo. Kem nahi? Any reason पण आपको? All of you are telling me no. But why no? You're right.
સર
Yes.
સર એ બધા પોઈન્ટ ઉપર સ્ટાર્ટિંગ પોઈન્ટ થી ઇન્ક્રીઝ થતું જાય.
That's not a right answer. Suppose we are considering the rectangle, that is nothing but your case of the uniformly distributed load. Yes or no? Yes or no?
Yes, sir.
Now parallelly I am consider triangle. Now center of the rectangle and center of gravity of rectangle, can I say that lies at the same point? Yes or no? કેમ કે symmetrical છે. Center and center of gravity બંને એક જ જગ્યા આવશે rectangle માટે. Yes or no? રેક્ટેંગલ નું પોતાનું
Yes,
સેન્ટર
sir.
અને જ્યોમેટ્રી નું સેન્ટર ઓફ ગ્રેવિટી ધેટ ઇઝ નથિંગ બટ ટોટલ લોડ જે જગ્યા લાગશે બધી જ વસ્તુ એક જ પોઈન્ટ લાગશે. બટ ઇન કેસ ઓફ ટ્રાયંગલ, સપોઝ ધીસ લેન્થ ઇઝ L, can I say that center of triangle at a L/2 distance? No problem. Center of triangle is at a L/2 distance, but your center of gravity point also located at L/2. Yes or no? Center of gravity L/2 point distance જ આવશે કે અલગ distance હશે? You can tell me
Same distance, yes.
why same? Why same? Just rethink and give me answer. Just compare rectangle and triangle. It is your symmetrical structure. Is this your symmetrical structure? I am telling now. Just listen to me very carefully. Just different two condition. One condition is your geometrical center. Okay. One condition is your geometrical center, and second condition is your distribution of mass no center. Okay, geometrical center to center માં જાવશે, geometrical center and center mass. But while I am considering distribution of mass, let me know distribution of load. Let me know your center is at center point or at different point. Students, is this your symmetrical structure? Is this your symmetrical structure? Chalo, first of all,
No, sir.
nothing. Barabar. Now, keep in mind your total load will be acting at a center of gravity point only, not a center point. This is your center point. I am telling about center of gravity point. In case of triangle, your center of gravity will be somewhat different as compared to center of triangle. Yes or no? This is a center of gravity point. Is it clear? Is it clear? Now, how to determine this center of gravity distance? Don't worry, we will learn that particular topic also after the completion of this topic. Okay, આ ચેપ્ટર પૂરું થશે ને પછી આપણે એ કવર કરવાના છે. એમાં આપણે એને ડિરાઈવ પણ કરીશું. Why it is not at center? Center પાસે તો L/2 distance આવવું જોઈએ, જે L/2 નહીં આવે, એક અલગ distance આવશે. Now, as we have discussed in yesterday's lecture, this total load will be at a center of gravity point. This total load is nothing but point load. Okay, this total load is nothing but 1/2 W into L. W is the load, L is the length. So now this distance, I think we have discussed these two distance. Yes or no? May I know apex લીધેલું? May I write this point is apex point? This line is the baseline. Yes or no?
Yes, sir.
So what is this distance? આ distance કેટલું કીધેલું મેં? 1/3 L કીધેલું, યાદ આવે છે? ના ડિસ્ટન્સ માં 2/3 L કીધેલું. આવું કંઈક તમે મેથેમેટિક્સ લેવલે ભણી ગયા છો. નાઉ ડોન્ટ વરી, હમણાં યાદ રાખી લો. યુનિફોર્મલી વેરાઇંગ લોડ નું ડિસ્ટન્સ સેન્ટર ઓફ ગ્રેવિટી થી જો એપેક્સ પોઈન્ટ કન્સિડર કરતા હોઈએ તો 2/3 L આવે. ઇફ આઈ એમ કન્સિડરિંગ બેઝ લાઇન, ધેટ ડિસ્ટન્સ ઇઝ 1/3 L. ઇઝ ઇટ ક્લિયર ઓર નોટ? પ્લીઝ કન્ફર્મ. એટલું ક્લિયર છે?
Yes, sir.
Okay. Now let me start new topic today. Types of beam. Before starting types of beam, first of all we are discussing types of structure or classification of structure. Types of, now we can classify types of structure based on number of parameters, but I am discussing here only one parameter. Okay? I am discussing only here one parameter because it is important. So based on equilibrium condition, we can divide types of structure into two parts. One is a statically determinate structure. Another is a statically indeterminate structure. Is it okay? Please confirm me. Is it okay?
Yes.
Now, question to all the D2D students. I think all D2D students learn already in diploma level what is a statically determinate structure and what is a statically indeterminate structure. May I write yes or no? Chalo. If you know the answer, type in chat box. This question is not for regular students. This question is only for D2D students. Chalo. Nothing cover the no law. Cover the law answer. ના ખબર હોય તો ના લખો અને આન્સર ખબર હોય તો એનો આન્સર. ચલો ફાસ્ટ.
સર પાછું બોલો દે.
What is the which kind of structure is known as a statically determined structure and which kind of structure is known as a statically indeterminate structure? My simple question, simple answer. My question is that what is a statically determined structure and what is a statically indeterminate structure? I think all of you have learned this topic in a structural mechanics subject, and semester is semester 3 of your diploma, if I am not wrong. Chaliye, mere ko my question is very simple. Please give me simple answer only. Don't give me any complicated answer. ખબર ના લખો અંદર ચેટ બોક્સમાં, નો પ્રોબ્લેમ. તમારે ખબર પડે મારે કઈ રીતે ચલાવવાનું. Again, your chat is also recording. ઠીક છે? Your internal evaluation based on your chat also. જે પણ ક્વેશ્ચન પૂછું છે એનો આન્સર આપશો, એના ઉપર પણ તમારું ઇવેલ્યુએશન મારા સબ્જેક્ટમાં થશે. So please be active during my lecture. Fine, fair enough. Statically determinate structure. Before explaining statically determinate structure, chalo, let me know how whenever we are considering the structure. Okay, so this is a kind of the coplanar non-concurrent force system. हमने वो विचारी लो, coplanar non-concurrent force system. Okay, આ ફોર્સ સિસ્ટમ કન્સિડર કરીશું. તમારી નંબર ઓફ કન્ડિશન્સ કેટલી થશે? નંબર ઓફ ઇક્વિલિબ્રિયમ કન્ડિશન કેટલી થશે? Write down in chat box. How many number of equilibrium condition? Chalo, this question answer open to all the students. બધા students answer આપશે. I want answer from all the students. Okay, 3. Fine, fair enough. Now my simple question to all of you. I know my simple question to all of you: if there is a three unknown and you have a 3 equation. Okay, again my question to all of you: if I have a 3 unknown and if I have a 3 equation, can I able to solve? Yes or no? Solve થાય કે ના થાય? Can I able to solve such problem? Yes or no? I want answer from all the 27 students. Please interact. Please interact. Simple question, simple answer જોઈએ છે. જે સ્ટુડન્ટ નો આન્સર આપે છે વિચારો શાંતિથી. If I have 3 equation and 3 unknown, can I able to solve that? Yes or no? Okay, fine. Again, second case is that if I have 3 unknowns and 2 equation, can I able to solve? Can I able to solve? Yes or no? My second question is that if I have 3 unknown and 2 equation, can I able to solve? Yes or no? This is your first case. Can I able to solve this system? Yes or no? This is case number 1. Answer મને કઈ આપશો? Case number 1 yes, case number 2 yes કે no. Okay, પહેલા મને case number 2 લખી લેવા દો, પછી આન્સર આપો. Case number 2, now can I able to this system? This is case number 1 and this is case number 2. ચલો તમારા માટે વધુ ઈઝી કરી આપ્યું. Case number 1 અને કે તમારો આન્સર આવી રીતે આપવાનો છે. Case number 1 આન્સર, case number 2 આન્સર. ચલો ફાસ્ટ, આપણે આ ટોપિક આજ પૂરો કરવાનો છે. ઓફલાઈન કરતા આપણે પાછા ચાલીએ છીએ. ફાસ્ટ આન્સર આપો. ચલો આપણે ઓફલાઈન ની જોડે થઈ જવાનું. Only one student give me answer. ફટાફટ ચલો. જે અહીંયા લખ્યું છે એ જ મેં ઇક્વેશન ના ફોર્મમાં લખ્યું છે, બીજું કશું નવું નથી. XYZ is your unknown and 3 is your equation. ચલો. Okay. So can I say that in case number 1 you have a number of unknowns equals to 3, number of equations 3. Are you able to solve? Yes. In case number 2, number of unknowns are 2. Number of equations, sorry, number of unknowns are 3. Number of equations are 2. Are you able to solve? No. Are you able to solve? No. So whenever your number of unknowns equals to number of equation, or number of unknown is less than number of equation, okay, number of unknown અને number of equation ની વેલ્યુ સરખી હશે, એવા સ્ટ્રક્ચર ને કહીશું આપણે statically determined structure. Now this is not a structural definition. I don't want a answer. Okay, મારા આન્સર નથી જોઈતો. I want only yes or no. ઠીક છે? I don't want answer. Fine. My number of unknowns and number of equations are same. Such kind of structure is known as a statically determined structure. અહીંયા લખું છું number of unknowns equals to number of conditions હશે. એ કેસના કહીશું statically determined structure. But whenever your number of unknowns is exceed number of equation, such a structure is known as a statically determined structure. That's it. Clear here? Now again, keep in mind, this is not an exact definition. This is a simple representation of the statically determined structure and statically indeterminate. Is it clear or not? Is it clear or not? Please confirm me.
Yes, sir.
Okay, now what is the number of unknowns? We will discuss later on. Don't. Okay, we will discuss later on. Now all of you are knowing the number of conditions. We have 3 number of condition. Yes or no? We have 3 number of condition. Yes or no? So એના બેઝ પરથી આપણે derive કરીશું કયું structure determination, કયું structure indeterminate. Now we will discuss. Now why I have this discuss? Because I want to start a new topic named types of beam. Types of beam. And lots many types of beam are determinate and lots many types of beam are indeterminate. So we will classify types of beam based on that determinants. So first type of beam is the simply supported beam. Simply supported beam. Chalo, write down in chat box for D2D student only. Which kind of support are there in simply supported beam? क्या सपोर्ट આવશે? चलो सिंपली सपोर्टेड. क्या सपोर्ट આવશે सिंपली सपोर्टेड बीम में? चलो फास्ट. ना खबर ना लखी दो. One support of the simply supported beam is the always hinge and another support is always roller. Is it clear? Is it clear? Is it clear? Simply supported beam નો એક સપોર્ટ hinge હશે, બીજો સપોર્ટ રોલર હશે. આટલું ક્લિયર છે? પ્લીઝ કન્ફર્મ મી.
Yes, sir.
Rasmi, I am not asking about fixed beam. I am asking about simply supported beam. Okay, whenever we are dealing with fixed beam, we will discuss that point. Okay. Now, simply supported beam, one end is a hinge, another end is a roller. Now, can I say this beam is a simply supported beam? Can I say this beam is as a simply supported beam? My question. Simple question, simple answer. Chalo. Simple question, simple answer. Okay. Now, just kiddu che, that's not your fault. But after some explanation, tell me. Now, તમે yes લખ્યું છે એમાં તમારો કોઈ જ fault. Okay, you are right. But after my explanation, then tell me either this is your simply supported beam or no. Okay, may I write? May I write? चलो. Hinge support पर कितना reactions आवશે? Just tell me. Hinge support पर कितना reaction आवશે? Tell me. चलो, write down in chat box. Hinge support पर कितना reaction आवશે? Write down in chat box. 2 vertical and horizontal. Yes, good. Roller support पर कितना reaction આવશે? Y still 2 3 और आज y3 બે જ આવે. Inclined નું reaction કરતા આવું કોઈ reaction જ નથી. Only 2 reaction, vertical and horizontal. Keep in mind. Okay, I don't know any inclined reaction. Only 2 reaction for hinge support and 1 reaction for roller support. Now, can I say that this reaction is nothing but your unknowns? Yes or no? This reaction is nothing but your unknowns? Yes or no? Chalo. Can I say that? આટલું ક્લિયર છે? આટલું ક્લિયર છે? કોઈના પણ ખબર ના પડે પૂછી લેજો. રેગ્યુલર સ્ટુડન્ટ ખાસ તમારા માટે નવી સિસ્ટમ છે. Can I say these reactions are nothing but your number of unknowns. Now tell me how many number of unknowns are here? કેટલા unknowns છે? Total unknowns કેટલા છે structure માં? Total unknowns કેટલા છે structure માં? Just tell me, ચલો fast. 3 yes or no? hinge પરના બે reaction ના
3,
roller
sir.
હા બરાબર. hinge પરના બે reaction ના roller પરનું એક reaction, so we have a 3 unknowns. Now as we have discussed just now, this is a beam here. આ એક તમારો beam છે બરાબર. So now આના ઉપર basically vertical directions માં load આવશે. So now whatever the load acting on this beam, just visualize that these loads are concurrent or non concurrent forces. જે પણ load લાગશે એ concurrent હશે કે non concurrent હશે? કયા પ્રકારનો લોડ હશે? ચલો just tell me.
શું sir ફરી કરો?
Now
Concurrent.
whatever load acting on the beam, which kind of the load acting, that is a concurrent or non concurrent? Just think and give me answer. Either it is a concurrent or non concurrent, including reactions also. Yes, you are right. Is it a concurrent or non concurrent? Chalo fast.
concurrent sir.
Why concurrent? Which kind of force are known as a concurrent? ચલો મને પહેલા એક જેણે આન્સર યસ તું એક જસ્ટ મિનિટ જેણે concurrent કીધું છે એ જ કહેશે, બીજું કોઈ નહીં કહે. ચલો why concurrent? આ બધા force એક જ પોઈન્ટ પર લાગે છે કે અલગ અલગ પોઈન્ટ પર લાગે છે? જસ્ટ ટેલ મી. What?
different point ઉપર લાગે ને sir.
આ તો પછી આનો concurrent કહેવાય કે non concurrent કહેવાય? અલગ અલગ પોઈન્ટ પર લાગે છે એનો concurrent કહેવાય કે non concurrent કહેવાય? લેટ ચલો. This is the non concurrent force system. Why non concurrent force system? Please go through recording. You are get that point answer. Clear? Now as we have discussed, this is a non concurrent force system. Now how many number of conditions available for non concurrent force system? We have already discussed. ચલો મને કહો કેટલી conditions available છે આપણી જોડે? કેટલી conditions available છે આપણી જોડે? Let me know. Give me answer in only chat box. કેટલી number of conditions available છે? Yes. No, don't write condition. Numbers લખો ખાલી. Conditions નથી લખી, numbers લખો. Okay, so we have a number of conditions that is equal to 3. So now why 2? 3 આવશે ને કોઈપણ non concurrent force system ની વાત કરું છું. So in this case your number of unknowns and number of conditions are same. That's the reason can I say this is a statically determinate structure? Yes or no?
Yes, sir.
આવું કંઈક ડિપ્લોમા લેવલે ભણેલા? Simply supported beam is a statically determinate structure. Now tell me how can I say this is the simply supported beam? Are you able to say this is a determinate or indeterminate from this arrow only? Can I represent just like this? બંને arrow નો wing support represent પણ કરી શકું છું. બંને support ને બે ruler support થી પણ represent કરી શકું છું. Yes or no? Yes or no? Yes or no? મેં આ વસ્તુને ફરીવાર represent કરી છે. Can I represent like this? Both hinge. બંને hinge આપીશ તો તમારા number of unknowns કેટલા હશે? Just tell me. બંને hinge આપીશ તો number of unknowns કેટલા હશે? Just tell me. Why 6? Simple calculation છે. 2 + 2 4 થાય. બરાબર ને? 2 + 2 4 થશે. Now if I am considering both ruler, number of unknowns કેટલા હશે? If I am considering both 2, clear? 2 હશે. ચલો ફાઇન, carry on. Number of unknown 4 છે તો આને statically indeterminate કહે તો ખબર છે બરાબર ને? statically indeterminate structure કહેવાય. Yes or no? તો આ પ્રકારનો સપોર્ટ હું પ્રોવાઇડ કરી શકીશ નહીં. May I write? Yes or no? Yes or no? ચલો now suppose હું બંને એન્ડ રોલર પ્રોવાઇડ કરું છું, but what about if I am applying horizontal load on your beam? તમારા બીમ પર હું horizontal load apply કરીશું, શું હશે? It will be remain stable or unstable? It will carry this load. It will carry this load, yes or no? We have provided roller like this. I want more answer. તમારા માઇન્ડમાં જે રોંગ ઇન્ટરપ્રિટેશન છે મારે દૂર કરવું છે. That's the reason. રેગ્યુલર સ્ટુડન્ટ નો કોઈ પ્રોબ્લેમ જ નથી કેમ કે એમને ખ્યાલ જ નથી. તમારે તો તમે ડાયરેક્ટ આ યાદ રાખી શકશો પણ જે રોંગ ઇન્ટરપ્રિટેશન છે એને આપણે રિમૂવ કરવું છે. સો નો ક્લિયર. સો નાઉ tell me there is any sense to provide two roller support at a time. There is any sense to provide two roller support at a time. કોઈ સેન્સ છે પ્રોવાઈડ કરવાનો? No. Okay, so your one now in this case, suppose there is a horizontal load acting on your beam. This horizontal load will be registered by this horizontal reaction, yes or no? Horizontal reaction register se કહી શકાય, yes or no? So our this structure is a stable one because horizontal load also carried by this reaction, yes or no? And we have discussed purpose of reaction to carry the load, to transfer the load, yes or no? So that's the reason. Keep in mind, for a simply supported beam, your one support is a hinge and another support is a roller only. Is it clear or not? Is it clear or not? Please confirm. Now tell me, are you still say this is simply supported beam? Are you still say this is simply supported beam? कैसो आने के नहीं को? Symbolically that's okay. Structurally કહી શકાશે. Just tell me this is a simply supported beam or not. આને હજુ પણ તમે simply supported beam કહેશો? તમને તમારી બુકમાં આવો બીમ આપે તમે એને simply supported beam હજુ પણ કહેશો? My question is that no. Why not? Explanation આપો. May I write? Is it clear or not? Is it clear or not? Clear? So simple explanation, simply supported beam વિશે લખવું એટલે લખી શકાય one end of the beam is a hinge, another end of the beam is a roller. Simply supported beam having a one span. Span that means member. તો એક સિમ્પલ વસ્તુ વિચાર, મારે એક મેમ્બર બનાવવો હોય કેટલા જોઈન્ટ જોઈએ? મારે એક મેમ્બર બનાવવો હોય કેટલા જોઈન્ટ જોઈએ? ચલો જસ્ટ ટેલ મી. મારે એક મેમ્બર ક્રિએટ કરો તો કેટલા જોઈન્ટ જોઈએ? બે જોઈન્ટ જોઈએ. one is the starting joint, another is the ending joint. Yes or no? Yes or no? મારે કોઈ પણ એક મેમ્બર ક્રિએટ કરવો હોય તો મારે બે જોઈન્ટ જોઈએ. one is the starting joint, another is the ending joint. Okay, so now for a simply supported beam we have two joints only. One is the starting, another is the ending. Okay, so we have only one span. Span is nothing but your member. Okay, this is a technical word. One span. We have only one span for a simply supported beam. One end is a hinge, another end is a roller. Such kind of beam is a statically determined structure. That's fair enough. There is a fair enough explanation for simply supported beam. Is it clear or not? Please confirm. Is it clear or not?
Yes.
Chalo, fine. Next, now question is that what is the example of the simply supported beam? Now practically simply supported beam kind of structure is appear in a steel structure, but if we are considering the RCC structure, so now I will give an example of the simply supported beam in a next lecture if you don't mind, because some further explanation is required. Is it okay? I will give an example of simply supported beam in our next lectures. Is it okay? Because some further explanation is required in terms of the some load carrying mechanisms. Fine, no problem. Let we learn last one more kind of the beam and then we will wrap up the session. The second kind of the beam is a cantilever beam. Second kind of beam is a cantilever beam. For a cantilever beam, one end is a fixed, another end is a free. Is it okay? One end is a fixed, another end is a free. Yeah, is it okay? Clear? થિયરી લખતો નથી. તમે જ્યારે રેકોર્ડિંગ જુઓ ત્યારે નોટ્સ બનાવી દેજો. બરાબર ચાલશે ને? થિયરી લખતો નથી. તમે જ્યારે રેકોર્ડિંગ જુઓ ત્યારે નોટ્સ બનાવી દેજો. For a cantilever beam, one end is a fixed, another end is a free. That means અહીંયા તમે કોઈ જ સપોર્ટ પ્રોવાઈડ નથી કર્યો. May I write? અહીંયા તમે કોઈ સપોર્ટ પ્રોવાઈડ નથી કર્યો. Is it okay? Now just tell me how many number of reaction at this support? This is point A and this is point B. ચલો point A આગળ કેટલા reaction આવશે? Just tell me. Okay, I want more answer. Okay, only two students give me answer. Regular students શું કરો છો? રેગ્યુલર વાળા કોઈ દેખાતા નથી. દક્ષ, દીક્ષિત, કૌશલ, દેવ શું કરો છો? આન્સર આપો. Only D2D students give me answer. D2D વાળાને તો ખબર છે એમના કન્સેપ્ટ ક્લિયર કરવાનો છે. એ ખાલી યાદ રાખી લીધું કે ત્રણ આવશે ને ડિટર્મિનેટ છે. કેમ એમને સમજાવી દીધું. ફાઇન, ચલો. So we have three unknowns. Yes or no? number of unknowns equals to 3. Now tell me, અહીંયા મારે રિએક્શન બતાવવાનું, અહીંયા રિએક્શન બતાવું પોઈન્ટ બી આગળ, યસ ઓર નો? પોઈન્ટ બી આગળ રિએક્શન બતાવવાનું કે નહીં બતાવવાનું? જસ્ટ ટેલ મી. કેટલા આ કે છે? યસ વાળા કેટલા? યસ વાળા યસ લખો, નો વાળા નો લખો. પોઈન્ટ બી આગળ, ઓકે, હર્ષ સેઇંગ યસ. પોઈન્ટ બી આગળ રિએક્શન બતાવવાનું, ઓકે. Why yes? Is there any support here? Is there any support here? Is there any support provided here? Let me know first of all. અહીંયા મેં કોઈ સપોર્ટ પ્રોવાઈડ કર્યો છે? અહીંયા મેં કોઈ સપોર્ટ પ્રોવાઈડ કર્યો છે? So why it is required to provide a reaction? સપોર્ટ જ નથી તો રિએક્શન પ્રોવાઈડ કરો. સપોર્ટ રિએક્શન ક્યારે આવશે? સપોર્ટ હશે તો આવશે, મે રાઈટ? રિએક્શન ક્યારે આવશે? સપોર્ટ હશે તો આવશે. સપોર્ટ ના હોય તો રિએક્શન આવે. સપોર્ટ ના હોય તો રિએક્શન આવે
ના આવે સર.
ના આવે તો અહીંયા રિએક્શન આવે. હવે મને કહો, અહીંયા રિએક્શન બતાવવાની કોઈ જરૂર છે? આવું લોડ બતાવવાનો, અહીંયા વર્ટિકલ રિએક્શન બતાવવાનું?
નો સર.
હા, ખબર પડી ને ડિપ્લોમામાં શું ભૂલ કરતા હતા એક્ઝામમાં? રિએક્શન બતાવીને આવતા હતા, એક્ઝામ્પલ ગણતા હતા, વીએવીબી ગણતા હતા. યાદ આવે છે એવું કંઈક? પણ પછી એવું વિચારતા મેં તો સાચો એક્ઝામ્પલ ગણ્યો છે, પણ એક્ઝામમાં કેમ ઓછા માર્ક્સ આવ્યા? આવું થતું હતું કે નહીં ડિપ્લોમા લેવલે? યસ ઓર નો? That's the reason my topic
Yes, sir.
So keep in mind, if there is a no support, no reaction. Again, our number of unknowns 3, number of conditions 3. Which kind of structure? કયા પ્રકારનું સ્ટ્રક્ચર હશે? Statically. કયા પ્રકારનું સ્ટ્રક્ચર હશે? Statically determinate કે indeterminate?
Determinate.
Is it clear or not? It is a statically determinate structure. Again, cantilever beam is a statically determined structure. Only one span, one end is a fixed, another end is a free. Now, example, beam in a balcony. Balcony માં જજો લેક્ચર પતે એટલે પછી પાછા આવી જજો ફટાફટ, બરાબર? લેક્ચર પતા પછી જજો, બરાબર? બાલ્કનીમાં જે બીમ હશે ને, જસ્ટ જો ઉપર જોવું પડશે તમારે. એ એરમાં આ રીતે અહીંયા ફ્રીલી મૂકી દીધો હશે અને લેફ્ટ સાઈડ કોલમ હશે, મે રાઈટ? અહીંયા કોલમ હશે ને ત્યાંથી કન્ટિન્યુઅસ એક બીમ રૂમમાંથી આવતો હશે, મે રાઈટ? This is your
Yes,
support. This column is nothing but your support. But અહીંયા તમે કોઈ સપોર્ટ પ્રોવાઈડ નથી કરતા, તે ફ્રીલી આવા મૂકી દીધો છે. That is nothing but simple example of cantilever beam. Is it clear or not? Please confirm. Is it clear or not?
Yes.
Any question in today's lecture? Any question in today's lecture?
No, sir.
Okay.
No, sir.
Very good. Just a
Okay.
minute. Okay, just a minute. I'm taking your attendance. Okay, any suggestions? If you are don't understand attending the teaching methodology, any suggestions? Any genuine suggestions? Most welcome. You want to change any teaching methodology, regular student, day-to-day student, બધાને પૂછું છું. Or it is clear to all of you? ખબર પડે છે બધાને?
Yes, sir.
Yes, sir.
Okay. Okay. Genuine feedback.
Yes,
only.
sir.
Very good. Chalo. We will meet again in, I think today our last lecture now. No last lecture. Okay. So we will meet again in next week. All of you having a very nice day. We will meet again in next lecture. Again,
Thank you, sir.
simple. Again,
Thank you, sir.
જે સ્ટુડન્ટના જે પહેલો લેક્ચર છે કે જે સ્ટુડન્ટના લેક્ચર્સ મિસ થયા છે, હું હમણાં લેક્ચર પછી એટલે ગૂગલ ફોર્મની લિંક પ્રોવાઈડ કરું છું. જસ્ટ ગૂગલ ક્લાસરૂમની લિંક તમારા ગ્રુપમાં પ્રોવાઈડ કરું છું. જસ્ટ ફિલ ધેટ ગૂગલ ક્લાસરૂમ. Sorry, just join that Google Classroom. After joining that Google Classroom, fill one Google form which is already posted in your Google Classroom. Okay, and at the end of the I will sharing all the previous lecture and today's lecture to all of you in your Google Drive. Picture. So please fill that that link if you don't have that particular if you don't have fill that particular link. Picture. Fine. So please complete that process so I am able to send a recording of the previous lectures. Okay, we will meet again in next lecture.